vuoi, io sono qua comunque, quindi
Ma
per ogni
voi
evidenza.
vedete tutto lo schermo o lo vedete in modalità presentazione?
Allora, vediamo il PowerPoint aperto, quindi
Ma non a tutto schermo?
non a tutto schermo ancora, no?
Ok.
Ah già, condividi schermo, hai ragione. Forse è quello. No, se da tutto schermo, bene.
No, è che da casa non vedevano a tutto schermo. Qua adesso vedono a tutto schermo e tu hai la visione da speaker,
Sì.
questa qua, e dovrebbero. Adesso
Perfetto.
adesso siamo online, quando vuoi. Sì.
Paolo, che faccia strana che hai.
Ci comunichiamo fuori. Direi che possiamo partire o vogliamo aspettare ancora un minuto di... Crea un po' di resistenza al mouse. Se si vedesse... No, non si può fare, non c'è più buchi.
Così, dai. Basta che mi ricordi sta roba lì.
Hai ragione. Perché sono... Ok.
Vabbè, dai, se ne facciamo così, piuttosto facciamo così, tanto mi adatto in qualche modo. Si già.
Non so perché hai veramente il puntatore sullo schermo.
Sì.
Quindi, cioè se vuoi indicare perché non
Il
stia...
puntatore, se devo indicare, non so. Niente,
no, cioè, è il mouse dello schermo.
vabbè, mi arrangio, dai.
Sta solo più.
Perché forse se questo veniva copiato in locale, poi c'è...
No, ma il problema non è del mouse.
Ah,
Il problema è che lui adesso il puntatore sta solo in quello schermo.
vabbè, senti, mi arrangio così.
Ok.
Cominciamo adesso?
Sì, secondo me sì. 11:05.
So I switched to English. We are in saving mode here, so there is no introduction. It's all homemade thing, so I introduced myself. We have the pleasure here today of hearing myself speaking about astronomy at the time of William Shakespeare. Today it's St. George's Day, 23rd of April, and it's also Shakespeare Day because it's thought to be William Shakespeare's date of birth and also the day he died. So many reasons why I thought, well, let's do just something a little bit different. And it's also lovely British weather. You can't see from outside here, but today it's a perfect London weather to have a talk about Shakespeare. It's not going to be specific about Shakespeare. It's mostly going to be about history of astronomy at the time of Shakespeare. That's an interesting time to be alive, because you can see the life of William spanned most of the astronomy revolutions of the 16th century, between the 1560s and first decade of the 17th century. That's where the most exciting things happen in the history of astronomy, from Copernicus to Kepler and the invention of the telescope and Galileo and so on. And also in UK or British politics, remember, most of the lifetime of William Shakespeare is under Queen Elizabeth I, and then the last few years under King James I, just to give you a general introduction of the situation. The astronomy revolution starts in 1543, when Copernicus publishes his famous book that is also nicknamed the book that nobody read. You can Google this, because actually it's only printed in about 250 copies. Very few people, it's written in Latin, it's dense Latin prose, very difficult to follow. Don't get me wrong, everyone looked at this famous illustration, they appreciated it, they remembered it, but very few people read the text. It's a bit like, they used to say the same thing with Playboy magazine. That's a similar situation. So if it was only for Copernicus' book, probably the revolution would not have started. What happens next is something that really captured the imagination of the people at the time. And that was in 1572, when you have a new star appearing in the sky. What now we know it's called the supernova in Cassiopeia. You can see here two drawings of the position of the supernova, one done by Thomas Digges, who was the most capable British astronomer at the time, and the other one done by Tycho Brahe, who was the most famous European astronomer. That was a huge surprise. It was the first time in recorded history that people have seen something changing in the sky. Now, it's true that in the Middle Ages, there were other supernovae, and we know that some people, for example, wrote something about the supernova of the year 1006 or the Crab supernova. But the fact is that in the Renaissance, people have lost historical memory of these things. So the only other recorded occurrence of a change in the sky for them was the Star of Bethlehem. Clearly, that was something related to the birth of Jesus Christ. So, of course, the supernova of 1572 must be something equally important. There were two alternative explanations. Tycho Brahe seems to prefer the idea that it's something new, either forming or starting to burn in the sky. In England, John Dee and Thomas Digges prefer a different explanation. They think it's an existing star that moved closer to the Earth to become visible and bright, and then after a few weeks moved back away from the Earth. It's an alternative explanation. You see, they say lowered from heaven to the sphere of Venus and retracted vertically back. What's important to notice is that this is the first time that astronomers apply the technique to at least try to measure the parallax. They compare observations done from different cities in Europe. It's the first time that you have this network of collaboration inside Europe and the UK, because they want to see if this object has a parallax, for example, comparing the position seen from England or from Germany or from Italy. And they find no parallax. It's too far to see parallax. So it's certainly not something that happens in the atmosphere of the Earth. It's something that belongs to the stars. That's a huge thing. It questions the idea that nothing can change in the sky beyond the orbit of the moon. It's very likely that this star of 1572 is the one mentioned in Hamlet when Shakespeare says that yon same star, that same star that's westward from the pole, had made its course to illume that part of heaven. Hamlet is set around about 1572. The action is set in either November or December, and the only bright star westward of Polaris visible from Denmark in November is supernova 1572. And the reference to this thing that the star made its course, it traveled to illuminate that part of heaven, seems to reflect the explanation given by Dee and Diggs about the star moving towards us and then moving away. Now, partly based on this idea that stars are distributed over a large distance, you have the improved Copernican model published by Thomas Diggs in 1576. You can see that the initial Copernicus model has the stars still confined to the outer sphere, to the thin shell outside. Thomas Diggs in 1576 believes that the stars are not in a thin shell, they are distributed throughout the universe. And in fact, he says, this orb of stars fixed infinitely up, extended itself in altitude spherically and therefore immovable. And then it goes on, the palace of felicity garnished with perpetual shining, glorious light, and so on. But his idea is that stars are distributed in infinite space, we would say isotropically, and in a kind of spherically symmetric. This idea is actually the same that was then revised by Newton when he was asked, why don't stars collapse onto each other because they are attracting each other because of gravity? And he said, well, that's because they are distributed uniformly in infinite space throughout the universe, so the gravity of each star is exactly balanced by the gravity of all the other stars. The importance of this booklet from Thomas Diggs 1576 is that it's the first discussion, the first explanation of Copernican theory in a modern language, the first time that it was translated from Latin into a living language. And instead of printing just 200 copies, this one printed something like 20,000 copies, which was huge at the time. So the importance of this booklet cannot be overstated. Maybe you should have found a simpler title. The booklet was called A Perfect Description of the Celestial Orbs According to the Most Ancient Doctrine of the Pythagoreans, lately revived by Copernicus and by geometrical demonstrations approved. Notice that he's saying not invented by Copernicus, but it's the ancient doctrine of the Pythagoreans, Aristarchus, for example, lately revived by Copernicus. That's 1576. 1577, that's an event that is pretty much forgotten in history's textbooks today. but that was huge at the time. That was the great comet of 1577. It's still one of the 5 brightest comets in human history. And it made a huge impression on people there. You can see contemporary engravings. This is over Prague. This is over Zurich here. There were dozens of books and articles written about this comet, not just because it was incredibly bright, but because it gave another chance to measure its parallax, to see again if this is something that happens in the atmosphere of the Earth or something that happens in the planets or the stars. And so again, as you may have guessed, Tycho in Europe and Thomas Digges in England go to work. They measure part of the comet, try to measure the parallax. These are original handwritten sketches by Tycho Brahe. They find no parallax, but they find also very interesting thing, that the comet is going around the sun. It's not going around the Earth. This is the first confirmed example of a body that is moving around the sun. And it helped a lot pushing the idea that maybe solar system bodies are actually moving around the sun, not around the Earth. So again, the importance of this comet in the history of astronomy, or history in general, is great. Not just in the history of astronomy as a science, but you probably know that in 1577, there was no real distinction between astronomy and astrology. So astronomers had to measure the trajectory of the comet, its brightness, but also they were expected to give a prediction of what the comet was going to do. Comets were not good signs. They were bringing excess cold, excess heat. They were bringing fires, floods, famine, wars, everything blamed on comet. All the things that today we can blame on CO2, at the time, they were blamed on these vapors from the comets. So people are worried. They see this incredibly bright comet they've never seen in their life. They say, wow, this is... The Prime Minister goes to Queen Elizabeth and says, stay indoor. Don't look out the window, please, because comets were also bringing what we call today regime change. Comets were famous for that. So the government says to Queen Elizabeth, pull the curtains, don't look outside. But you know, Queen Elizabeth had heart of a king and everything. So she says, I don't care. She goes to the window, she pulls open the curtain, she opens the windows, looks outside and proves that she can look at the comet and nothing happens because she's stronger than the comet. She says this famous sentence, sapiens dominabitur aspris. The wise person will be stronger than the influence of the stars. We should write this thing here at the gate outside. Very nice sentence. Sapiens dominabitur aspris. The reason she was so strong and so confident about her power was because, according to the official Tudor chronicler, her contented mind, her harmless thoughts, her temperance in diet, abstinence from excess of all things that offend, moderation of exercise. So that those were Queen Elizabeth's strengths. Unfortunately, other countries in Europe were not so lucky to have a sovereign like Queen Elizabeth. And so great problems were going to happen according to the astronomers. For example, this is a professor of astronomy at the University of Copenhagen, and he's predicting bad things happening in Hungary, in Spain, sorry, Andres, if you're listening to this talk, in Germany, and so on, in Moscow, Sweden, Wallachia, in Calabria as well. Don't know why specifically Calabria and not other parts of, but anyway. Famine and pestilence, what's happening there, especially for pestilence dear time. So not a good time. Tycho Brahe is even more pessimistic and even more specific. Tycho Brahe writes that the comet will bring again pestilence. plague and poisonous sickness, unknown infirmities. The sun will bring unnatural heat and then turn around an unnatural cold, and strong winds in winter, gruesome cold with sharp wind. The Jews will suffer great persecutions, for a change, but also it's going to be very bad news for the Catholics, see, monks, priests, and of the Popish religion. Now keep in mind that Tycho Brahe was funded by a Protestant king, so surprising, he finds the comet is very bad news for the Catholics. He also predicts war in Russia, especially the southern border of Russia, which is like predicting rain in London. But there's a silver lining for that, because he says that the good news is that this comet might bring a well-deserved punishment upon those presently reigning in Moscow for the inhumane tyranny which they have practiced so long, and perhaps even bring about an end to their wantonness. By the way, there is this year in October, there's this comet called the Purple Mountain comet. It's going to be quite bright, so just keep an eye and see if that one can do the trick. I'm not sure. Now, partly based on the success of this program of observations of supernova and the comet, Tycho Brahe gets a huge funding grant from the government of Denmark, something like 1% of Denmark's GDP at the time. And he can build Ranibo, 1580, and then Stjernborg, 1581 to 1584. So every year there was something really happening in astronomy at the time. And that's where he devises his famous model in which the Earth is still in the center, but all the planets are moving around the sun. And then the sun and all the planets are moving around the Earth. Now, mathematically, that's perfectly equivalent to the Copernican system. If you just set the origin of your coordinate system at the Earth's position, that's what you see. The only difference was that the fixed stars were still in a thin shell. So from this point of view, Thomas Digges was much further advanced, and they were symmetrically located around the Earth, not around the sun. Tycho's model became a favorite model in most of continental Europe for several decades. It's only when it became possible to measure effects like the aberration of light that the Copernican model was proved, or Kepler's model became dominant. 1583, 1585, another milestone in astronomy. We have Giordano Bruno visiting London. Giordano Bruno was more of a philosopher rather than an observational astronomer, but he was even more ahead of his times, even more than Copernicus or Tycho or Thomas Digges. He was talking about a universe that has no borders, no limits. The sun is just another star, and the stars are other suns. There is no center. That's, again, a revolutionary idea, much beyond the existing Copernican model. Bruno wrote most of his most important pieces of work during those 3 years in London. The problem is that he had a bad attitude. He argued with everyone since the time he set foot in London. He would insult all those who disagree with him. He would insult his academic colleagues. He would insult the same people who were supposed to find him a job at Oxford University, or were supposed to give him grants. He said that the English people were too stupid to understand him, and they were xenophobic against Italians, and vice versa. English people were mocking him because he had a thick Italian accent when he was lecturing, and he was gesturing like that. He said he would pull his sleeves up and then he would gesture like this and shout and insult people. Many people went to listen to his lectures, not so much because they wanted to hear what he had to say, but because they enjoyed the show of this Italian guy shouting and arguing with people. That's a rare image of one of his lectures. But he did make one friend during this time in London, and that was John Florio. John Florio is an intriguing figure in English Renaissance. He was a linguist. He was the writer, the compiler of the first Italian to English dictionary. He was fluent, like a mother tongue, in English, Italian, Spanish, Latin, and he could also read Greek and French. He was the English tutor at the French embassy. Then he became the Italian tutor for the Queen, and he was possibly also the editor of the first folio, the book that published Shakespeare's plays. But he always kept a low profile, and today we know that that's because he was also paid to be a spy. When he was the English tutor in the French embassy, he would spy on the French and then meet Queen Elizabeth and tell her what he heard from the French ambassador. And he was a friend of Giordano Bruno, and he was quite interested in astronomy. I'll mention him a little bit later in this talk. 1588, another big year in European history. That's when the fiery trigon begins, according to astronomers and astrologers. You know, the different epochs in human history are divided into epochs dominated by signs of air, fire, water, or earth. Every 150 years, there's a change in the dominant sign of the zodiac. That depends in which signs you have conjunctions between Jupiter and Saturn. 1588 is the beginning of the epoch dominated by signs of fire. And that usually brings revolutions, wars, changes, and so on. So 1588 was predicted to be a very bad year. People were actually scared. Today, we don't read about this in history books, but 1588, people were scared about it. They believed these astrological predictions. Well, what happens? Nothing bad happens. Well, I should say nothing bad for England. Andres, yes, I know. Sorry about Spain at the time in 1588. Not really a great year. But in England, everything is fine. Astrologers have, and also astronomers have eggs on their faces because prediction failed. Shakespeare mocked this failed prediction, this fake news in Henry IV. He's talking about this old guy with young girl, and he's saying, oh, well, look at this conjunction between Saturn and Venus. Are you sure that the fiery trigon agrees with this conjunction? It means that he knew about this thing, and people in his audience also knew about these things, because otherwise they would not understand these jokes. So we have an idea of what the average English middle-class member of the audience would know about astronomy. Okay, astrologers and astronomers, then they say, well, okay, we got it wrong in 1588, but that's because we made a mistake. It's not so important the year when the fiery trigon begins. The most important thing is when you have the first big astronomical event within the fiery trigon. And that event was going to be the conjunction between Jupiter, Mars, and Saturn in October 1604. It doesn't get any bigger than that. It's something that happens only once every 800 years in the signs of fire. The previous time was when Charlemagne was crowned emperor, and the one before was the birth of Jesus Christ. So talk about big expectations. That's because Jupiter symbolizes the new world, growth, progress. Saturn symbolizes the old world and death. And Mars, between them, symbolizes war. It's a catalyst. War to go from the old system to the new system. And when this conjunction of three planets happens in a sign of fire, fire multiplies everything exponentially, and you have this big thing that must happen somewhere. The triangle in the trigon. It's like the Thriller in Manila, something. Even more than that, 1604 is the 33rd year since that miraculous star of 1572, which was associated with the Star of Bethlehem. Now it's the 33rd year, so maybe there would be something associated with the death or resurrection of Jesus Christ. Astronomers measure the position of the planets. The planets get to their closest approach on the 9th of October, 1604. Everyone is looking at the sky, looking at these three planets and saying, well, come on, something must happen there. And what happens? Boom! A new star there, exactly that night, exactly between these planets. Brighter than Venus, a naked eye supernova. That's what we call today supernova 1604. That was a huge sensation. They got it right. That's, you know, people were really impressed with us predictions, right? Obviously, Kepler, well, Tycho was dead by then. Thomas Dix was dead. Kepler, who was Tycho's student, takes on the job of studying position and the light curve of this new star. That's his drawing here. So it's the Impede Serpentarium, in the foot of the serpent. We have an impressive light curve of this supernova, including the rise phase. It got up to a brightness of -3. And we have this beautiful light curve, considering it's from 1604, precisely because every astronomer in Europe was looking at this region of the sky on the 9th of October, 1604, to see if something was going to happen there. Kepler tries to measure the parallax. Again, no parallax. So that is definitely not something that happens in the Earth's atmosphere. He writes his famous book, De Stella Nova. Half of it is about the astronomy part of his study, light curve and position and so on, and half of it is the astrological interpretations. It's easy to find English and Italian translations of the first half. Second half, pretty much forgotten, only the original Latin text. He says, we can certainly rule out that this happened by chance, because no way that it's something that just a random encounter of matter that goes off exactly in that place, that night. You know, you can't believe that, you know, just that, no chance. But at the same time, it cannot be produced by Jupiter or Saturn because they are material bodies. So it must be a message from God. It must have some kind of spiritual meaning. Why did God put this message right there? Well, because he knew that everyone in Europe was looking at that part of the sky that night. Just like, you know, placing a TV commercial during the Super Bowl. I'm paraphrasing a bit. It's text. He didn't use these words, but that was the point he was trying to make. And then he goes on summarizing all the possible interpretations, material and spiritual interpretation of this message from God. He says he doesn't have any elements to prove one or the other. He doesn't want to take sides, because if he favors one or the other, it will trigger violent arguments between himself and every other astronomer in Europe, because each one has a different opinion, and he doesn't want any of that. He wants to stay out, says this famous thing, because me bonum et pacificum Germanum. So don't mention the war. And then the rest is history. You have the invention of the telescope. You have Kepler's Astronomy Nova with the elliptical orbits. You have Galileo's book. And by 1614, remember Shakespeare died in 1616. By 1614, in England, the heliocentric model becomes the accepted model in the intelligentsia, in the universities, unlike continental Europe, where Tycho is still dominant. And in fact, there's an interesting commentary here from 1614. John Berkeley says, nowhere in the world outside England do you find as many people who believe and support the Copernican system, even if they don't know exactly why, simply because by doing so, they show that they are superior to the common people who are still believing in the old geocentric system. It's a very interesting observation. England had this advantage in adopting the Copernican system, mostly because Thomas Digges had written that nice popular booklet explaining that, instead of just leaving it to discussions in Latin universities. England made good use of this advantage. Now, was Shakespeare a believer in geocentric models, heliocentric, or the Tychonic model? Well, there are three schools of thought here. You can find PhD theses and articles saying that he believed in the Ptolemaic system because he says, oh, sun, you moved in this great sphere. But then you have those people who say, no, he was a Copernican, because he says that he doesn't think that the sun is moving. And then you have those who say, no, he was a Tychonic supporter, because in Proetus and Cressida, he says the Earth is the center, but the sun so is enthroned in noble eminence and dominates over the planets. So you can interpret it in all three possible ways. Now, Shakespeare has been interpreted as many times as Nostradamus, sometimes. But certainly Shakespeare was interested in some details of astronomical knowledge. You see, in All's Well That Ends Well, there is a dialogue between this guy called Parolles, who is hitting on a young girl called Helena. He's trying to impress her, and he's saying, I'm a great warrior, I was born under Mars. And she says, yeah, you were born a lot under Mars. He doesn't get the joke, and he keeps going, I'm a great warrior. And Helena says, yeah, you were born when Mars was retrograde, because when you fight, you tend to go backwards, like Italian tanks. I'm joking, in English. Anyway, so that's a very subtle joke. It means that people listening to this play knew about the fact that some planets sometimes apparently move backwards in the sky. That was one of the issues of debate between the Ptolemaic and the Copernican system. It's like today making jokes about the Hubble tension or something. So he knew something about astronomy. And then he had several references to stars that get out of their spheres. A star dissolved, beautiful word that nobody used before Shakespeare and nobody used after Shakespeare. Before Shakespeare, people didn't imagine that stars could move out of their sphere. So the analogy wouldn't work. And after Shakespeare, celestial spheres were pretty much abolished, removed. It talks about unsphere the stars several times, several different places. And the common interpretation is that he's referring to Thomas Digges' idea that stars like the two supernovae were moving closer to us and then moving away again. There's even a place in Cymbeline, which was written around 1610, when he mentioned the apparition of Jupiter coming down on Earth, and Jupiter is surrounded by 4 so-called apparitions or ghosts going around them. And there's been a lot of speculation that that was the 4 satellites of Jupiter that were discovered that year. We'll never know. It's a possibility. And then you can take things even further. There's a professor at University of Pennsylvania called Peter Usher, who has made a career out of trying to interpret everything in Shakespeare as a code for astronomy, in particular Hamlet. Lately, he found a supporter even within enough, Enrico Massaro. You can have a look on ADS, you can find this paper by Massaro and Usher. So what's the point here? He's saying that everything in Hamlet has to be read as an allegory of the debate between the Copernican system and the Ptolemaic system. So for example, Prince Hamlet represents heliocentrism, maybe Dix or Bruno. Claudius is, of course, Claudius Ptolemy. Rosencrantz and Guildenstern represent Tycho, and so on. He has a metaphor or analogy for anything you can think of. Now, why Rosencrantz and Guildenstern are supposed to represent Tycho? Not just because they're Danish, because when you look at famous Tycho's portrait, he put here a list, coats of arms of the families of Danish aristocracy to show that he was related to the best of Danish aristocracy. He wanted to show that he was a noble person. And two of the families he was related to are the Rosencrantz family and the Guildenstern family. So it's very weird that Shakespeare uses these two names, Guildenstern and Rosencrantz, in Hamlet. Is it because he saw these two names in Tycho's portrait? Well, there are alternative possibilities. Some scholars say that it's because there was a delegation of two Danish ambassadors to the English court, to Queen Elizabeth at the time, Frederick Rosencrantz and Knut Guildenstern, who were always traveling together. They spent a couple of years in England. Now, that doesn't really solve the problem, because then the question is, how did Shakespeare know that there was a delegation of Guildenstern and Rosencrantz meeting the Queen? He wasn't part of those meetings. It's a big mystery, not solved yet. It's intriguing. The other intriguing thing is that Uraniborg is just off the coast of Denmark. This is Hamlet's castle, Elsinore, and this is the island of Ven. So essentially, Hamlet can see Uraniborg from his window, closer than Russia, just off there. Again, intriguing. Just chance, who knows? It sounds believable. The problem is that there are so many allegorical readings of Hamlet. So there are people who say that Hamlet is an allegory of the war between Catholics and Protestants, and that Shakespeare was Protestant or an Anglican or a Catholic. There are all three interpretations. Hamlet can be an allegory of the war between England and Spain. There is a Freudian interpretation of Hamlet as a manifestation of Oedipus complex. You can find all these papers online. It's an allegory of the life of Christ. It's an allegory of Plato's philosophy. Then, of course, it's also an allegory of LGBTQ something. It's Shakespeare, in the character of Hamlet, is a homosexual queer theory, critical queer theory. I think there could be even a Marxist interpretation of Hamlet. Well, there is now, certainly. Anyway, so it's hard to know what to believe, but that's a possibility. And this is intrinsically linked to this age-old question of who was William Shakespeare, or I mean, who actually wrote plays signed by William Shakespeare. There are people who say that William Shakespeare was a brand name or a pen name, and somebody else was writing them. These are the four candidates that are usually put forward, the most likely ones. I'm not saying that it's likely, but candidates you always hear are the Earl of Oxford. So you have the Oxfordians supporting this thesis. You have the Baconians supporting Francis Bacon. The Marlowians saying that it's Christopher Marlowe. And then there's William Stanley, Earl of Derby. But there are at least 24 candidates to be the real writer of Shakespeare's plays, including, and I kid you not, including Michelangelo Crollalanza from Sicily. Somebody said that that was the real identity of Shakespeare. And probably bottom of the list, that Shakespeare was, in fact, Sheikh Zubair, get the point, Sheikh Zubair, a Muslim writer from Iraq. Again, it was a serious suggestion from someone in the Middle East. Again, we don't know who really was Shakespeare, just like who killed JFK. There's also an alternative possibility that Shakespeare was the producer or the supervisor of the project, but the final written or printed text was written or suggested by somebody else. So it was a collaboration between two people. Maybe William had the idea, maybe he wrote the first draft, but then it was polished by somebody else. And this somebody else has been suggested to be John Florio. That was one of the suggestions. Florio certainly could have provided astronomical knowledge because he was interested in astronomy, he was a friend of Bruno. He would have provided all the references about Italian and Latin books, all the stories that Shakespeare borrowed from Italian literature, and he was a linguistic genius. He would have polished all the puns, invented new words, and so on. Again, nobody knows. It's at least something to think about, because, I mean, there have been other famous artists in history who were great because they had a good wordsmith behind them. So it wouldn't be the first case. I'm trying to think of someone like Baptiste Mogol, right? That could be the only, or Ambra and Boncompagni, if you remember, right? He was always suggesting. So that could be the situation of Shakespeare and Florio. Who knows? Well, what's the alternative? The alternative is that William Shakespeare is indeed the guy from Stratford, and he wrote everything himself. So then the question is, where did he learn astronomy? Because he didn't go to university, he couldn't read Italian, he couldn't read Latin. He wasn't invited to debates in the main universities. So who told him about these things? A possible answer has to start from Thomas Russell. Now, Thomas Russell is a brilliant enough fellow. He published a paper in Nature last month. He's a good friend of mine, but this is a different Thomas Russell. This Thomas Russell was a good friend of William Shakespeare's. We know that because he's one of the few people who got some money when Shakespeare died. He's one of the few people mentioned in his will. Got about £1,000 in today's money. He was also the overseer of Shakespeare's will. That is the person in charge of making sure that Shakespeare's will was enacted. So the people who were supposed to receive land or a house or furniture or money received it. So they were friends, and they were also almost neighbors. They lived along the same street. So we know that. Now, Thomas Russell was the second husband of Anne Silliger. So probably William also knew Anne. Second husband because Anne was a widow. She remarried when her first husband died. Anne's first husband was a scientist. And as you may have guessed by now, that's why I'm diluting this thing just to raise the expectations. Anne's first husband was Thomas Digges. So here's a nice connection to astronomy. Thomas was the son of another scientist, Leonard Digges. Their son, Leonard Jr., was a poet, and he was also a friend of William. In fact, Leonard Jr. wrote the preface to the first volume, which I mentioned before, might have been edited by John Florio. So it's a small world. At least there is a possibility of this connection. Maybe William learned astronomy from Thomas and Anne Digges. Anne Digges' man called Thomas, apparently. But anyway, what else did Thomas Digges do for astronomy? And I'm getting to the end of this talk, the last 2 or 3 slides, because, okay, we mentioned it many times. Yeah, he measured the parallax, wrote the first Copernican book in English, observed the comet, invented the idea of infinite space, but what did he really do for astronomy after all? Look at this description in this 1576 book, perfect description. He's trying to convince people that Copernicanism makes sense. And he uses the analogy of a ship sailing on the sea. And he says, if you are on a ship moving along at constant speed on the sea, you think you're stationary. And if a man should softly let a plummet like a hammer fall down from the top along by the mast, even to the deck, this plummet passing always by the straight mast. The same if you are on a moving ship, you drop a hammer from top of the mast falls down parallel, sorry, the hammer falls down parallel to the mast. This is what we know today as Galilean relativity. Galileo used the same analogy. If you're on a ship, you don't realize that you're moving. And he took the credit, but in fact, this was 60 years before Galileo. The same analogy was used by Digges. If you dig into his work, you find other interesting things that have been kind of forgotten. There's this book called Phantometria, where he teaches techniques of triangulation to measure angles and distances. And he mentioned something called perspective glasses. I try to adapt the original English into something a little bit more modern, but he's describing experiments that he did with his dad, Leonard Sr. And he's saying, from here, my father, by his continual painful, he means painstaking practices, assisted with demonstrations mathematical, was able, and sundry times had, by proportional glasses duly situated in convenient angles, proportional glasses duly situated in convenient angles, not only discovered things far off, read letters, numbered pieces of money with the very coin and superscriptions thereof, cut by some of his friends at purpose upon downs in open fields. So he could use this frame of proportional glasses to see things far away, read letters, texts, see what's written on the coin, but also 7 miles off, declared what had been done at that instance in private places. He could see things happening 7 miles away. He had also sundry times and so on. So he's describing something made of glasses with which he can see things happening miles off. That's in 1570s, early 1570s. And then he keeps talking about this thing. He's saying, marvelous are the conclusions that may be performed by glasses concave and convex of circular and parabolical forms, using for multiplication of beams, sometimes the aid of glasses transparent. By these kind of glasses, or rather frames of them, very specific, not just by this kind of glasses, but frames containing these glasses, placed in due angles, we may not only set out the proportion of the whole region, but represent before your eye the image of every town, village, and so on. Goes on saying that with this kind of thing, you can see things very far away. The standard interpretation of this text is that he was imagining what could have been done with a set of lenses. To me, this sounds a very detailed description, not just imagining. It sounds like he actually tried to do that, in which case that would be the first instance of a homemade telescope. Well, again, we'll never know. He talks about the miraculous effect of perspective glasses. So that could have been the first invention. He didn't follow up on that. Why? Because he was a very busy man. He was doing lots of different things. He promised to write a book on proportional glasses in which he would have described how to make these frames, and he didn't write it because he started to do other things. He was elected as a member of parliament at Westminster at the exceptionally young age of 26. That's 3 years younger than Giorgia Meloni when she was elected, according to Wikipedia. He moved from astronomy into military engineering and ballistic motion. He started to calculate how to combine the motion of cannonballs, the linear motion and the vertical motion, the same thing that Galileo would be doing and other scientists. That was a very important problem at the time. He worked as an MP. He wanted England to adopt the Gregorian calendar. But unfortunately, that came from Italy, from the Pope. So the parliament voted against that because even if it was a good idea, it can't from Pope, you can't adopt the Gregorian calendar. It took another 150 years for England to move to the Gregorian calendar. And then he became the commander of the British Army in the Netherlands during the war between the Republic of Holland and Spain. It's intriguing to think that maybe when he went to the Netherlands, he must have discussed the possible use of proportional glasses for military purposes. We don't have any written letters or anything, but I can't believe that he didn't talk about that when he was there as a possibility. And maybe that sparked some interest, who knows? And finally, he died at the age of 49. So maybe he should not have worked so hard in his life. So what's the conclusion? That's my last slide. Apart from the fact that maybe you shouldn't work so hard as Thomas Diggs. Well, because he was quickly forgotten after that, by the way. It's really sad. There's no street, school, monument in the whole of England to remember Thomas Diggs. Very unfortunate. Well, my last slide is just to remind you that sometimes history books say that 16th century was a revolution from like the medieval ideas to the modern ideas, from superstition to science, from geocentrism to heliocentrism, but it was much more complicated than that. There were many different open questions at the same time, and you had scientists on both sides of the argument, or scientists on three sides in some cases. Each of them had some partial evidence in favor. So you had not just the issue of geocentrism or heliocentrism, you had the issue of finite or infinite universe, you had the issue of whether the spheres were solid objects, orbs, or only mathematical ideas, planets moving along orbits, not orbs. You had the debate between an unchanging, steady-state universe or an evolving universe with things that can appear and disappear. You had the debate on whether changes are random collisions of things, or new acts of creation, new things that appear, and whether they are messages from God, as Kepler thought. And debate on how these things influence human life. So that's very intriguing things. We still don't know what some of the participants of this revolution thought on any of these things, but I think it's very intriguing and it's much more complex than we normally read in textbooks. And that's why I just wanted to have a bit of fun today with this talk. And thank you for listening. So if you have any questions or things that I haven't been clear, I'm quite happy to continue chatting.
Se avete domande da casa potete scriverle in chat.
In any language, you can write them in English, Italian, Latin, Piedmontese, or French.
Or maybe you can raise a hand and you can ask questions directly on the mic.
No question?
Solo una domanda in italiano.
Ah, vengo.
Dunque, tu hai parlato della grande congiunzione di Giove e Saturno nel 1572 e hai detto che inizia l'epoca dei segni di fuoco.
Okay, so the question,
Spiegalo un po' meglio, perché-
okay, the question was about the great conjunction of 1604. What does it mean in the fire signs? You have 12 signs of the zodiac, 3 for fire, 3 for water. Jupiter and Saturn tend to have conjunctions in signs of fire for 150 years, because it depends on the Saturn has a period of 30 years, Jupiter 11 years. So it's rare that you have these conjunctions. And what happens is that you have these conjunctions always in signs of fire for a number of years. That's the diagram here that shows, and then you have them always in signs of water and then always in signs of air. For example, at the moment, since a few years ago, the last conjunction in 2020 was in a sign of air, which is good news for people born in sign of air. I'm Gemini, so great. That's why I got a mini grant last year. And that's for the next few decades. But at the time, from 1588 onwards, for about 100 and some years, all the conjunctions would have happened in signs of fire. Okay, so that is just, but that is conjunction that happens every maybe 30 or 40 years. What made it so special was that it was not just a conjunction of Saturn and Jupiter, but it was a conjunction of Saturn and Jupiter plus Mars, plus it was happening in a sign of fire. And it's this thing altogether of having those three in a sign of fire that happens every 800 years. And it was already known to be something really exceptional because of the story, Saturn being the old world, Jupiter being the new world, Mars being the war between the old and new one, and it happens in a sign of fire, which kind of triggers this war. And that is what people were waiting for. I don't know, well, so 800 years, so it means that it has not happened again since 1604. It will happen in 2200 and something. So yeah, we will not be here to see what happens next time.
Domande dal pubblico? Online? No. Possiamo concludere qua. Grazie a tutti. Commento personale, mi è piaciuto come tematica, cercheremo di replicare cose di questo tipo ogni tanto durante l'anno. Va bene, alla prossima. Ciao ciao.
È stato molto simpatico, effettivamente, qualcosa di fuori.
No, vabbè, tanto per divertirsi un po' di tanto.